Hey everyone, good morning. I'm Priyanshi Agrawal and welcome back to my YouTube channel. Now we are going to see today's Leetcode daily challenge, which is maximum value of an ordered triplet. First, okay, so let's see what is this question and how we can solve it. So in this question, you are given a zero index integer array nums, and you need to return the maximum value over all triplets of indices I, j, and k, such that I should be less than j and j should be less than k. If all such triplets have a negative value, then you need to return 0. And the value of a triplet of indices I, j, k is equals to nums of I minus nums of j multiplied by nums of k. Okay, so what you have been given in the question is a nums vector array in which you need to return the maximum value among all the triplets, and triplets are defined in such a way that I should be less than j and j should be less than k, and the value of triplet will be this nums of I minus nums of j into nums of k, and you need to maximize this value. Okay, so one very basic brute force approach which comes to our mind while after reading this question is that we can simply start three nested loops and calculate the value of this triplet, right? Yeah, we can do that. Okay, so the constants are also 10 to the power 2 only. So if we use three nested loops, then also it will be 10 to the power 6, which is obviously going to work. Okay, so yeah, one thing we can do this, we can start in three loops where we will initialize I with 0, j with I plus 1, and k with j plus 1, because I should be less than j and j should be less than k, and we will simply calculate its value and maximize it. So the time complexity of this approach will be n cube, and space complexity will be obviously big of 1 as we are not using any extra space, and this will going to work. But if the constraints are not this much easier, then how can we solve this question? Like, can we reduce the time complexity of this question to some extent? Okay, let's see. So like in this approach, we are iterating all the three variables. We are not assuming something, we are not assuming anything. We are iterating over all the three variables. Okay, so let's see with this example 1, 10, 3, 4, 90. 1, 10, 3, 4, 90. So let's say you have three variables I, j, and k, right? I, j, and k. Cool. And we need to find the value of nums of I minus nums of j into k, into nums of k, right? So can you see something from here? Like, if we need and maximize this value. So if you want to maximize this value, then nums of I should be maximum, right? If you want to maximize this complete value, then nums of I should be maximum, only then we can maximize it. Okay, so instead of iterating all the three variables I, j, and k, can we fix j and k and keep maximizing I? Okay, let's see what I'm saying. Let's see if we will run a loop from k equals to 2, k is less than n, and k plus plus. It means initially our k is this, j is this, right? J is equals to 1, j is less than n, and j plus plus. And we will initialize our max prefix, which will give the value of this nums of I with nums of 0. And we will keep maximizing this nums of I inside of this j loop. Okay, so let's try dry run this, what I am saying. 1, 10, 3, 4, 19. That's something like this. We will initialize one loop this and then this j loop, and then initialize this max prefix and keep maximizing its value. Okay, so let's dry run this. 1, 10, 3, 4, 19. Cool. So initially our j is this, k is this, right? And our max prefix is 1 because it is nums of 0, right? Okay, so what, and our result, now let's update our result with max prefix, which is 1 minus nums of j into k. So obviously it is a negative value, so we can just write it as 0. Okay, now j can't move forward, right? So we will move our k, and our j will again start from 1, and our max prefix will again be initialized with nums of 0. Cool. Now let's update our result again which is max prefix minus j into k. Again it is going to be 0 because it is a negative value. Now let's update our j to this point. Let me just take this here. So let's update our j to this point and update our max prefix as well from the maximum of max prefix and nums of j, which was 10. So we will update our max prefix to 10. Now let's update our result 10 minus j into k. So we have got our answer 28 till now. Okay. Now let's again, j can't move forward, so we move k, and again j is pointing to this location, which is I equals to 1, and again max prefix is storing the value of nums of 0. Cool. Now again let's calculate our result, which is max prefix minus nums of j into k, which will be 0. Now let's move our j and update our max prefix with maximum of max prefix and nums of and j. So now let's again calculate the value 10 max prefix minus nums of j into this, which will be 7 into 19. Now let's again move our j pointer, again update our max prefix with maximum of max prefix comma nums of j. All it is already the maximum value, so we will not update it. Update our result, which will be 10 minus 4 into k, so it will be 6 into 19. So you can see the maximum value was 10 minus 3 into 19, which is 19 into 7. Cool. So in this way we can also get our value while fixing j and k and maximizing the nums of I at every step. So in this way we have reduced the one loop of I. So the time complexity is reduced to n square, and this space complexity is still big of 1 because we are not using any extra space. Okay, this is obviously going to work because its complexity is less than the previous approach. Okay, but can we reduce these two loops to a single loop? Like in this loop we are fixing j and k. Can we just fix k and keep maximizing I, j and something? Okay, so let's see. So you will need to find this value, right? So from this complete value, in the previous approach we are fixing j and k and maximizing I. Okay, but what if we fix only k? So then what we need to do for maximizing this complete value, this nums of I and minus nums of j should be maximized, and nums of I should also be maximized, right? For maximizing this complete value, if we are fixing only nums of k, then nums of I minus nums of j should be maximized and nums of I should also be maximized, right? So what we can do, we can fix the value of k and keep maximizing these values. Okay, so let's see what I am saying. So in this I max and d max, the difference and the I value. So we will keep maximizing these values while fixing the while fixing the k. Okay, so let's see with that same example, I 1, 10, 3, 4, 19. 1, 10, 3, 4, 19. Cool. So we will initialize three variables, that is result, I max and d max. Cool. Yes. Okay. So let's see with 0. So let's see how we can do this. So what we can do initially, we just need to find, like initially our k will be pointing to this point. So difference into k. So let's update the value 0 into 1, obviously 0. And then we will need to update our d max and I max. Oh, sorry, I have updated this in d max. Yeah, we will need to update the result. Okay. Now we will need to update our d max and I max. It means we need to maximize their values. Okay. So let's update our d max first, which is going to be I max minus nums of k. I max is 0 minus nums of k, it means 1. So it will become negative. So we will updating with the maximum value, so it will still remain 0 only, right? But why we are updating it with I max minus nums of k? Because obviously I max is the ith value, and nums of k is going to be our jth value for our next iteration, and we are maximizing it because we want to maximize the difference. Only then we can maximize that complete value. Okay, now let's update our imax with maximum of imax comma nums of k. Why we are updating it with nums of k? Because for the next to next iteration, this is going to be our imax, right? This is going to be our I. Okay, so now that in next iteration k is pointing to this location, now let's update our result with dmax into nums of k. Dmax is still 0, so result will still remain 0. Now let's update our dmax with maximum of dmax comma imax minus nums of k, so dmax will still remain 0. Imax we get updated with 10. Now that's k is pointing to this location, again dmax into nums of k, which is 0. Now again dmax, let's update our dmax, 10 minus nums of k, which is 6. Cool. Now let's update our imax with maximum of 10 and 3, it will still remain 10. Now k is pointing to this location. Let's update our result, which will be dmax into nums of k. It means 6 into 4, 24. Cool. Now let's update our dmax with imax, which is 10 minus 4, which is 6. Oh, sorry, earlier it was 10 minus 3, it means it was 7. So 7 4s are 28. So it was 28. Cool. Now let's again update our 10 minus 4, which is 6, but dmax is already 7, so we will not update it. Now let's update our imax with the maximum of nums of k comma imax, so it is already maximum. Now k is pointing to this location. Okay, so let's update our result again in dmax into nums of k, which is 19 into 7, so it will get updated with 19 into 7. Cool. Now let's update our dmax and imax again, but we have already go out of bound with this array. So our final answer is 19 into 7. And in the above approach also our answer was 19 into 7. So yeah, you can see that if we are fixing k and maximizing the difference and the ith value, then also we can get our answer. So in this approach we are using only single loop, so its time complexity will become big of n, and as we are not using any extra space, so its space complexity will become big of 1. So yeah, see how we have done this question in big of n time complexity. So yeah, that's all for this question. I hope you get it, but if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys, see you in the next video.